Okay, let's wait for people. Guys, am I audible? Am I visible? Hello, hello, hello. Good evening, good evening. Okay, so should we begin? Okay, so hello, my name is Saurabh Suryavanshi. I am from Mumbai, Maharashtra. I work in Euron as a developer along with five other members, and today I'm going to give you an overview of the architecture, the system design architecture of our entire platform from start to finish. Okay, so let's start. Okay, so first let's go to Euron. Okay, let's imagine a user journey. He discovers about Euron. He goes to Euron.1 and then he see this page. Okay, so first of all, our website is created in Next.js, Node.js. Okay, let me share my screen once again. Okay, I hope my screen is visible now. Yeah. So I was talking about the tech stack that Euron uses. So first we have Next.js for the front end, Node.js for the backend. For our database, we are using Postgres SQL. Okay, and in Node.js, we use a routing framework called Express.js. So let's start with a user journey. So first, user comes to Euron. Okay, so what happens is this web page gets loaded. This is a Next.js application which is hosted on AWS Amplify. User goes to the page and he gets served this web page from AWS Amplify. Okay, and then this web page, it makes a request to our backend which is written in Node.js, and it is deployed on ECS, which is Elastic in Container Service from AWS. So first the Node.js app is containerized using Docker, and then it is deployed on Amazon ECS. So after the deployment, this Express.js Node.js app, it goes to our DB, which is the PostgreSQL DB, and then which is hosted on AWS RDS, which is a managed SQL service. Okay, so our basic architecture is clear here. So user comes here, he discovers this website, he encounters this feature called reels. Okay, let's say he clicks on it. So he discovers the reel. So he wonders how this reel is made. Okay. So on the back end, for for this reel to be visible to the user, first our Euron team has to upload that reel. Okay. So first they go to our dashboard, which is our Euron dashboard. They upload a video called video.mp4. Then this video cannot be played whole here because the standard HTML video tag, it cannot take like it needs a video. Okay, so this let's say this is a 60 MB video. If we just upload it directly and try to run it here, okay, so first the browser will have to fetch 60 MBs worth of video, which will take a hell lot of time. Okay, so what we have done is we use a technology called HLS. So for video transcoding, what happens is This video first gets uploaded to our dashboard, then gets uploaded to a storage service, which is S3 in AWS. The video file is stored in S3. Then what happens is we have a video processing service. This service pulls the video from this bucket, and once there is a video in this bucket, it fetches it and processes it into a protocol which is called HLS. Its full form is HTTP live streaming. Okay. So what this does is this breaks the video, the whole video, into small parts of, let's say, 1 MB each. Let's say this is a 60-second video, which is 60 MB. So it breaks down the video into small chunks of 1 MB each, of approximately 1 MB. Okay. So here we have 60 chunks. So what happens is after this video gets put right here, it gets processed, it is stored again into S3, the final processed file. And what happens is here when we try to play the video, we use a package called hls.js. What this package helps us with is the normal HTML video tag. It only accepts MP4 videos, etc. So the full videos, okay? So using this hls.js app, what happens is this processed file is stored in a format called m3u8.m3u8. Okay. .m3u8, and this is the index file of the whole video, and the segments file is called .ts. Okay, so every video has one m3u8 file made and multiple ts files made. In this case, we have 60 ts files. Okay, so what happens here is hls.js first fetches the m3u8 file and then fetches the first .ts segment. The benefit of that is that the first segment of this is only 1 MB. So the video starts playing immediately. Okay, let me see if I can see. You can see that the video plays immediately, and then subsequently the following TS files are fetched as the video plays. Okay. After the video is playing, it goes to next video, and the same process repeats itself. By the way, this effect, which is snapping the reel, it is called CSS scroll snap. You can explore it more. Okay. Okay. So the bytes part is done. Let's say the user likes a byte. He tries to click like, but a pop-up appears which says login to interact. So he goes to, but he doesn't have an account, so he goes to sign up. Okay. Here we have two options, OTP and Google login as well. So let's explore the Google login first. Let me clear this. So what happens is here when we click here, sign in. From the user, it goes to our backend. Backend in the end communicates with a Google OAuth server. OAuth. Google OAuth server. The backend basically asks, is this user valid? If this user is valid, then please give its details. So Google says, yes, this user is valid. Here are its details. So the backend gets its detail. The account is created and we get logged in. Okay. So after logging in, let me see. After logging in, he can explore all the offerings of Euron. Let's say he doesn't have an email and he wants to log in through a phone. So he clicks sign up. Here he enters his mobile number. Okay, let me get the OTP once again. There is an issue here. Okay. Okay, so after he has logged in, let's log in. Okay, so he can also receive the notifications. Let's explore the system design behind this notification. Okay, so we are using an open source service called Novu. It is an open source service which we are using its cloud version, which is Novu Cloud. So it integrates with all the major one notification providers for email, for messages, etc. For in-app messages also. This is called web push in-app notifications. And for the SMS provider, we are using SNS. So when we want to share any notification, we just go to our dashboard. We send the notification content to Novu. It then goes to SNS, which in the end goes to the user, the end user. Okay. So in this case, we are using the web push, which is directly integrated into the Novu. So it directly goes to the final user. Okay. So the notification part is done. Any questions till now? Okay. So let's go to the next part, which is the course part. Okay. So let's say the user likes this course C++ A to Z. He clicks enroll now. This is the Razorpay dashboard. Okay. So when the user clicks on enroll now, what happens is the request goes to Razorpay first. Okay. As you can see, this is the Razorpay like a modal. It first goes to Razorpay. And when he completes his payment, Razorpay sends a request to our backend saying that this this user has completed the payment. Here are the details. And then through our backend, the user gets granted the course access. Okay. Now, Razorpay uses a technology called webhooks for this API. Now, why webhooks? So generally our backends are not exposed to third-party services. To expose our backend to third-party services, we create something called a webhook, which of which URL we send to the third-party service, which it can call. The major feature of webhook is that it can retry. So let's say Razorpay tries to call our backend, but for some reason it is not able to reach it. It will try again after 3 seconds, after 5 seconds, after 10 seconds. So incrementally the time increases, but the chances of delivery of this message from Razorpay to our backend increases to almost 99%. That is a major feature of webhooks. So next, related to payment, we have another feature called partnership. So if a user, let's say, shares a course, let's click on the share, and he goes, and his friend just clicks on the link. Here you can see we have attached a ref. So using that ref, if the user signs up, if another user, let me log out here. Let's say I am a new user and I go here and I sign up. So what will happen is that uh, the user which has signed up, he will be affiliated to the user of which ref this is. Okay. So whatever after that the signed up user does, like buying a course, buying our plan, whatever payment he does, 50% of it will go to our affiliate. This also uses Razorpay's service called Razorpay X, which is used to do from enterprise to user payments. Okay. So let's move on to the next. So let's say user joins a topic. Let's say user enrolls in some course. Okay. Then he goes into the live class. In our live class, the video, this is our page, this is our video, and this is the chat. Let's go into them one by one. So for the video, we are using a third-party service right now through which the video plays, but the chat is our inbuilt. What happens is that the user is connected to our backend, which is called the live chat server. So it is a separate service in our backend. The user connects to it using a library called Socket.io, which uses a technology called WebSockets, which allows real-time communication. Which allows real-time communication between two parties. So what generally happens is, this is our client, which is our browser, and this is our backend. Generally, what happens is that the browser has to request to the backend for some information, which the backend then verifies and sends back. But for the chatting, it to be real time, such that if there are multiple people, which are multiple browsers, which can send messages, and these messages should be visible to other users as well. So for that technology, we use WebSockets, and the library using which we have implemented WebSockets in our Node.js backend is called Socket.io. So using this, the browser which sends which sends the message to the backend is available in real time to the other users as well. For this, we use web chat. Also, in our live chat, we have, if a user asks any doubt, asks, it goes to our backend. The backend verifies whether this message is a question intended for an instructor. If this is, it goes to an LLM, which in our case is Llama, and the provider of it is Grok. Why Grok? Because it is super fast. Even if you check our Euron assist, we are using Grok here also. I don't have a plan here. Okay, let me log into another one. Okay, so here we have Euron assist. Here we can ask any question like what are generators in Python? As you can see, this is super fast. This is because of Grok. Grok uses LPUs for processing this request. You can check about this later, what is LPU. So the backend first verifies it, first verifies the question, like is it a question or is it a normal chat message, hi, hello, etc. If it is a question, it then we verify this using LangChain, by the way. It then asks Llama through Grok, and then it gets a response, and which gets sent back to the browser. Okay, the user which has asked it. Also, for our backend, we are using something called RAG, which we will talk about later. Okay, so let's say the user has watched the live class, and then next day he has to watch the recording again. He wants to watch it. So he goes here. Right now we are using a third party for the video delivery as well, which is called, this system of delivery is called VOD, which is video on demand. The user requests to play the video and then he plays. But we are also working on an in-house system. I'll just take you through the architecture of that as well. So what happens is that this is our Euron dashboard. If an admin, our admin uploads a video here, let's say it is called video.mp4. It goes into S3. It gets stored into S3. Now this S3, it triggers a Lambda function using AWS Event Bridge. It triggers a Lambda using AWS Event Bridge. Using Event Bridge, you can set up rules that such that if any objects are stored in this file, any objects are stored in this file, then trigger this function. Okay. So after this Lambda is triggered, what this Lambda does is that it takes the name of the video and then triggers a media convert job, elemental media convert job, which processes the video. Now, why all this is necessary? So playing, if you are a video platform, all your content should be protected such that it cannot be stolen by pirates. So we have to encrypt our video using a technology called DRM. DRM, which is digital rights management. So we use a third party for the DRM also. Now, why do we need DRM? Because anything anything which should be encrypted from the hardware side. Okay. So how exactly the system in which you are playing, let's say you have a Windows laptop or an Apple Mac, etc. For that system, it should be encrypted. So the hardware handles the DRM part. The hardware handles the decryption also, which lets you play the video. And if, let's say, the user is trying to record the screen or screen sharing or a meeting, this video will be completely black. Only the audio will play. This is called DRM. For this, the process is a little different from Reels management. Why, I'll tell you. So when the user when the admin admits the video to, uploads the video to the dashboard, it gets triggered into a media convert job, which needs to transcode it into two different protocols. The first is dash MPEG dash to be specific. And the second is the one which you used, HLS. Now you might be thinking, why do we need dash and HLS both here? In Reels, we were only using HLS. So the Reels content which we play, it is not DRM protected. So that's why we do not need multiple protocols for it. But for this, we need multiple because HLS videos will not play on Windows laptops on Chrome. But and also similarly, Dash content cannot play on Safaris on Apple Macs. Okay, so for that we need to transcode it into different protocols. Also, while transcoding, we need to ensure that the video is getting converted into multiple qualities. So let's say the video is uploaded in 1080p, the quality levels is high. So which means the video size will also be very high. So we need to convert it into different qualities. Let's say 720p, 360p, and then the original quality, which is 1080p. So why do we need this? Let's say the user is not in a very good network condition. So he cannot play 1080p videos before waiting for a long time. So the video will buffer a lot. So what we can do is we can convert it into different formats, which depending on the format, the video files which were very less, and also subsequently the video will play in each network condition. So this was the basic of DRM. Also, yeah, one thing. During this encryption, it contacts the DRM vendor, which is the third party service, and then encrypts it. And while playing also, we have to provide the credentials of the third party vendor to be able to play the video. Otherwise, it will not play. In the new in the modern world, we also have a protocol called CMAF, which eliminates the use of wanting or needing to use two protocols. So you just need one protocol, which is CMAF, which eliminates the need of these two. Because of this, the file size in your S3, the video which will play here will be less. So your cost is reduced a lot. So this was the LMS part. So let's say you were watching a video in our LMS and you got some doubt. You can come to Euron Assist. You can come to Euron Assist and you can ask it any doubt. Like what are functions in programming? And you can get an immediate answer, okay, about all your doubt. Now, what is different about this Euron Assist is from ChatGPT, etc., is that it knows about Euron. If you ask what is Neuron, you can see Euron is a edtech founded by Sudhanshu Kumar, ex-founder, etc., etc. This is different from ChatGPT because if you ask ChatGPT, there are chances that it will have to search the web to know about Euron. But Euron Assist doesn't need to do that because it is fine-tuned using a technology called RAG. RAG, the full form of RAG is Retrieval Augmented Generation. So using this, you can train ChatGPT, Llama, or any model, any open source model, I must say, on your data. So we have trained it on the data of Euron, like what is Euron, and we are improving it to include information about the courses, what has happened in the courses. So all of this will be available soon using the RAG system. In this also we use LangChain and various other stuff. Now, let's say Now let's say you watch the videos and then it is night time. You want to read some books. So you come to books. Let's say you come to book and then you enroll in it. So this book PDF is also stored in AWS S3, and this is a PDF package that we have used to view the PDF. Okay, so here you can jump directly to pages, multiple pages. Yeah, so that was the overview of the system design of Euron. If you have questions, please ask. We'll take questions for 10-15 minutes and then we'll end the session. In coming days, will you come up with system design also? Yeah. In a few months' time, we'll also have, say, a few days' time. We'll also launch a system design course. Yeah, any more questions? More about, we want to know more about the ref system. So what happens is that when you go to partnership, let me share my screen again. Let's say you go to the partnership, you share some, you can see that there is a ref attached here. If you copy this link and you paste it here, you can see that there is a ref here. This ref literally means referral. This ref means referral. So the user which is sharing this link, it is his ref. So anyone who signs up with this, the backend knows that this person has come through this person's referral. So any benefit, the commercial benefit which this user has done through payment will also be shared to the person whose ref he has consumed. Okay. System design. System design will come in days or months. Yeah, it will come in a few days. Just wait. We'll announce it. Yeah, I think we can end this class. Okay, guys. Thank you. This was my first class. My name is Saurabh, and we'll meet you again. Okay. Thank you.